Hello everyone, here are the security feature updates for our iOS XR 721 release. We will start with password policy for user secret. You might already be aware that iOS XR supports password policy for AAA secrets. The options include setting length or lifetime of secrets, max authentication attempts, and a few more. However, this was only supported for Type 7 passwords so far, and what is changing now with iOS XR 721 is the extension of this support to other types of secrets. That includes Type 5, Type 8, Type 9, and also Type 10 based secrets. This is applicable to both local and remote users. Here is how a typical configuration would look like. One can configure the password policy in the global configuration mode, and the options available are listed here. There is also a show command to verify the configured password policy. The next feature is about .1x port control on NCS platforms. Currently, iOS XR supports only single host mode where only one device can be connected to a port. With iOS XR 721, we are now going to support two additional modes listed here. In multi-auth mode, we can have multiple hosts on a single port. However, each device must go through authentication independently. And this is the default mode on all the ports. The other addition is multi-host mode where we can again have multiple hosts on the single port. The difference being, here only the first device needs to be authenticated, and rest of the hosts behind the first device can use the port without any additional authentication. And lastly, 721 release also adds support for allowing VLAN tagged traffic on .1x authenticated ports. In this case, the VLAN IDs are expected to be pre-configured, and for any untagged traffic coming on the port, there will not be any default VLAN assignment. The last feature is about some new guidelines for enabling FIPS in 721. FIPS is mandated as part of US and Canadian government certification standard that defines the requirements for cryptographic modules. Here are some of the new guidelines to be followed when enabling FIPS mode on the routers. The current session through which FIPS mode is being enabled must be configured with a FIPS approved algorithm. If not, it gets rejected. Any session using HMAC SHA based algorithms must have key strings of at least 14 characters. Telnet configuration gets rejected if device is in FIPS mode. And any existing Telnet configuration that was done before enabling FIPS mode will remain unused but won't be deleted. For additional information, you can refer to the FIPS configuration guide for NCS series platforms. Thank you.
Hi, this is Akshay Kumar Sankaran, Technical Marketing Engineer from Cisco MIG team. So this feature that we are looking at is going to augment the existing DHCP client behavior on the NCS 5500 platform with the new XR 721 software. So the first feature that we are looking at in this series of DHCP client features is the DHCP v4 and the DHCP v6 client option on the BVI interfaces. A quick recap on the BVI interface itself. It is a layer 3 context that we essentially require to stitch the layer 2 context again, or the bridge domains that is within the routers that we can configure. So essentially, so far, this BVI interface has been manually configured. With this new feature that we have added, we can configure this BVI interface itself to be a DHCP v4 or a DHCP v6 client that is helping us to configure the device for zero-touch provisioning kind of use cases. Moving on, we now have also added the DHCP v6 client behavior on the management interfaces. We have been having this DHCP v4 client behavior on the management interfaces for the zero-touch provisioning kind of behaviors. Now with the v6 move, you can actually move these NCS 5500 with the same zero-touch provisioning kind of requirements in your new management domain that is v6 enabled. The last feature that we have also added for this DHCP behavior is including the newer options for the v6 client. The first of these is the option 15 that is going to let us identify the type of users or applications. The next option, the option 16, is going to help us identify the vendor IDs. The 23 and 24 options are going to help us request the DNS server lists and also the DHCP domains that we can later use for our queries. Now we will look into the demo of this and see how these can be configured. We are looking at a device which is the Cisco NCS 5508. This is running the XR721 version, as you can see. And in this specific device, I have already configured the BVI interface. So I'm going to quickly show you that. So here you could see the BVI interface is configured as a DHCP client here with all the DHCP v4 client options. So this is essentially how we could stitch the layer 2 context of the bridge domain with this DHCP client behavior. Now moving on, I have also on the same box configured another BVI interface for a DHCP v6 client that we will be looking at now. Here you could see that this BVI interface 102 is configured as an IPv6 DHCP client with the options 16, 15, 23 and 24 that we saw earlier, and also other options such as rapid commit, etc. Let us also now make sure that this is configured properly and the control plane is working. Starting with the v6, you could see that the timers are configured and behaving as expected, and also you could see the link local addresses and the MAC address, etc. Likewise, let me also quickly check the v4 part of it. Here you could see again I have the DHCP v4 client configured on the 101 BVI, which is again able to do this specific DHCP query, and it will aid us in the DHCP client behavior. The next feature we are looking at is the support for BVI or the layer 3 interfaces on a bridge domain that is terminating double tags. So far, we have had support for single tag termination, that is single VLAN tag that is on the attachment circuit terminating on a bridge domain that can have the layer 3 BVI context on the same box. With this new feature support, we can now have possibly the service providers like cable providers who have the requirements such as double tag being able to have the direct termination or on the layer 3 interface for the BVI. Let's quickly look at this feature in a quick demo. First, let's look at the configuration that I have for the bundle interface and the layer 3 BVI interface. Here we can look at this bundle interface, which is the layer 2 transport with the double tag encapsulation with the outer and inner VLANs, that is 200 or the 100 here. And you can also see the specific command which says rewrite ingress tag pop2 symmetric, which kind of explains that this is the double tag environment here. And I also have the layer 3 interface with the BVI layer 3 addresses for IPv4 and IPv6. Now, to confirm that these are tied together and working as expected, I can also see the interface statistics, the operational status of this interface. You could again see the bundle interface, the inner and outer VLANs that's configured as expected, and the BVI. Currently the attachment circuit is down, so that's the reason we see it as down. And the layer 2 VPN context that is tying things together again has the attachment circuits, the BVI 100 with the layer 3 context, and the bundle ether 100 or 100, which is the layer 2 transport here. Thank you.
So bidirectional forwarding detection, or BFD, is used to detect faster connectivity failures and optimize convergence time. With this feature, we're extending the support of BFD to the default gateway redundancy technologies like HSRP and VRRP. VRRP is considered to be a standard in this industry and has been available on NCS 5500 since the very first year of the product history. HSRP, on the other hand, is a Cisco proprietary technology, and it came into the picture much later with iOS XR711. So, the purpose of BFD here is to detect a failure of default gateway in less than 1 second, significantly faster than the handshake mechanism used for VRRP and HSRP to perform a re-election. We have some important limitations to keep in mind. First, the feature is supported on physical, sub-interface, bundle, and bundle sub-interface, but not over BVI today. Also, HSRP and VRRP don't support RP failover. In terms of configuration, it will be done under the VRRP and address family. 1001 here represents the VRRP virtual address, and 1003 is the opposite interface IP tracked by the BFD. And a very similar configuration here is used for HSRP. Another feature related to BFD has been added in 7.2.1. It's the specific case where you configure unnumbered bundle interfaces, that means link aggregation, with no specific IPv4 or IPv6 address, and relying on the lookback interface address. If you want to configure BFD for such an interface, it's now possible, and you will have to specify the remote loopback address as displayed in this configuration example. Moving on to a totally different technology, let's talk about the file mirroring, a feature introduced in 7.2.1. If you are running a system with two route processors, you probably know it could be cumbersome to copy file from one RP to the other, and this feature is here to simplify the process. Once you enable it through configuration, the content of the folder /mirror on a hard disk will be automatically replicated. Let me show you that with a very quick demo. We run the test on a chassis with two RPs, RP0 is active and RP1 is standby, and we are running iOS XR 7.2.1. In configuration mode, we pass mirror enable and we commit. The folder named mirror in our hard disk is empty, both on active and standby. Now I copy the running config on this folder, and I can see the file .cfg is present here, and it has been automatically duplicated on the standby RP. Simple. Last improvement for today is relative to the number of bridge domains per system. Up to version 6.5.1, we supported 250. In 6.6.2, we increased this number to 750. In 7.0.2, we doubled it to 1500. And in 7.2.1, it's now 2000. See you in the next one.